We are three scientists at the Scripps Institution of Oceanography that have come together to work on an important problem with global connections and regional implications. Art Miller is a climate and ocean scientist, a climate ocean modeler.
Yeah, I'm a physical oceanographer who likes to work on a couple climate problems and also talk to the biologists. And my main expertise is in modeling. Sasha, on the other hand, is more of a statistician using data to look at atmospheric issues.
And you all know what a statistician is. It's somebody who doesn't have enough personality to become an accountant. But putting that aside, I like to work on many different things, climate related, but I'm mostly in the atmosphere. Diego Macias Moy is visiting us from Cadiz, from Spain, and he's a biological oceanographer.
Yeah, I do most of my research on dynamic of the ocean, and now I'm trying to work with these people in problems with related coastal dynamic of the ocean and long-scale climatic issues.
And we kind of sketched the whole California coast here with the Pacific Ocean next to it to give you a little perspective on what we're interested in.
Yeah.
There's a lot of things going on here. There's the clouds associated with the marine layer over the coast. There's currents in the ocean that bring nutrient-rich waters to the surface and drive the marine ecosystem here. And there's really interesting issues about how this system will change in the future and how that will impact the economy, both in terms of fisheries production as well as in energy usage along the coast. And
yeah.
Sasha's going to explain something about that.
I would actually also say how it will affect health, because we know from recent study that heat waves are increasing in frequency, intensity, spatial extent, and duration, and most importantly, they're becoming more humid in California. And the reason for that is a warming off the coast of Baja California, which looks puny on this graph, but actually it's much longer in reality. And when heat wave circulations set in, they bring air from this region into California. The warming of this region, which is actually the outflow region of the California current, creates this situation that heat waves are, that the air, the hot air that causes the heat waves is actually becoming more humid as well. And it's interesting that the humongous and unprecedented heat wave of 2006, which had unprecedented impacts on health in terms of mortality and morbidity, most of the people who died lived in the Central Valley, which was very hot. But the largest increase in hospitalizations and emergency department visits, morbidity in other words, occurred along the coast. And that's because the marine layer, which normally protects the coastal areas from hot temperatures during heat wave events, wasn't there. And people were not acclimatized to the heat that resulted. And actually, this California current is a very cold area of the ocean because of the upwelling, which is what we are going to study here. And as the land heats up, it causes a sea breeze, which brings the water that was sitting over the warmer open ocean over the cold California current, where it cools, and the moisture in it condenses, and it causes a slow, thick cloud cover along the coast. And it is very good for protecting the coastal areas, where most people live in California, against dangerous effects of heat. And obviously it also affects energy demand. Diego, do you want to say a couple of words about the upwelling system?
So, we're trying to relate the dynamic of the coastal upwelling with the climate in the Pacific Basin to try to forecast the dynamic of the upwelling based on the low frequency signal which are present in the climate index. This way we will be able to forecast in advance what will going to happen with the marine layer and the related issues with the health, with the energy, and also with the fisheries in the California region.